Today we will be doing the lab number 2, that is circuit simulation using SPICE, CMOS, NAND and NOR. This lab will be a bit easier for you because you already know how to simulate the bigger circuits. The objective of these labs are to identify and the mark nodes of the different NAND gates and NOR gate, to create the circuit files of NAND gate and NOR gate, to analyze the circuit using SPICE transient analysis capability. That means we will be drawing NAND gate or NOR gate. Then we will be finding or creating the circuit file for NAND gate or NOR gate. Then we will see the transient analysis. Okay, what is a CMOS NAND? This is a NAND gate. Why? Why this is a NAND gate? Because see, what is the output equation of NAND? Y is equal to A into B bar, right? NAND. That means multiplication and bar. That is the NAND gate. So they are multiplied. So they will be in series in NMOS. And they will be in parallel in PMOS. Now here 2 is given. That was calculated by using 2:1 ratio. But since in our lab it is 3:1, right? Since in our lab it is 3:1, so we will be using, wait a minute. We will be using 3:1. And how do I know that it will be 3:1? Shortcut. The law I have shown you in our previous theory class, that was okay. That was based on this formula: 1 divided by beta n reference, right, is equal to 1 divided by beta NA plus 1 divided by beta P. Now beta P, not beta P, this should be beta N. Beta NB, right? That was the formula. Okay, so if you use this formula, you can find the ratio, but there is a shortcut. Shortcut means when there is no problem, in that case, you can actually find, okay, how many, since this is one path, so how many MOSFET do you have in this path? 2, right? So this is one path. In this path, you have 2 MOSFET. So the sizing will be double. Normally, so let's use 3:1 ratio here. So 3 is for PMOS, 1 is for NMOS. So normally we have 1. Since we have 2, so it should be twice. Twice the normal ratio. Twice the normal number. Normal number is 1. Since we have 2, so it will be twice. So 2, 2, both of them. Now here, how many paths do you have? You have 2 paths. One is this one. Another one is this one. So in this path, how many MOSFET do you have? 1. So 1 time of 3, that means 3. How many MOSFET do you have in this path? You have 1 MOSFET, so it will be 1 time. So 1 time 3 means 3. So this is the shortcut. So if you use shortcut, you can use the shortcut, no problem. But there is a definite case of not using the shortcut. Okay, there will be some cases where you cannot use any shortcut, but in this case we can use the shortcut. That's normal. But if you want to use normal method, you are welcome to use the normal method. You can use that. You should use that. Shortcut method can give you some bad result as well. Okay, now 3322, right? So let's code. Let's make our code 3322. Remember, this is 22, this is 33. So let's make our code. Then find the circuit file. Okay. Okay. Now, where is our previous doc file? Let's see. Not that. We have a text file, right?
স্যার
হ্যাঁ
হচ্ছে কি আমার কোশ্চেন ছিল,
বলো।
হচ্ছে কি আমরা তো বেটা পি দিয়ে হচ্ছে কি ডাব্লিউপি বের করতে পারি, কিন্তু হচ্ছে সেখানে তো ডাব্লিউপি বাই ডাব্লিউএন এর রেশিওটা আমরা মানে অ্যাজিউম করে নেই না, এটা কি আমরা যে কোনো কিছু অ্যাজিউম করতে পারি?
না, আমরা যে কোনো কিছু অ্যাজিউম করতে পারি না। আমাদের এই রেশিওটা হবে 2:1, মানে 2:1 থেকে 3:1, মানে 2 থেকে 3 টাইমস। তবে আমরা আমাদের ফার্স্ট ল্যাবে কি দেখলাম, আমরা আমাদের ফার্স্ট ল্যাবে দেখলাম না যে আমাদের একটু ওয়েট করে দাও, আমি এটা খুঁজে বের করে নিই আগে, একটু দাঁড়াও। Where is the text file? Text file, text file. Yeah, here is the text file. ওকে, আমরা আমাদের ফার্স্ট ল্যাবে আমরা ওই যে কম বেশি করে বের করে দেখলাম না যে যদি আমরা এটাকে 12 করি, and if we make it 4, if we make it 12, and if we make it 4, then what happened?
পারফেক্টলি হয়, মানে হচ্ছে যে
হ্যাঁ,
2.8।
exactly, then it would be perfect. Now what is 3, what is 12, what is 4? See, 12 is to 4, right? 12 is to 4. This is WP, this is WN. So from there, if I divide these with 4, it come what? It comes 3:1, right? So in our case means in these material cases, so we use some material. A material গুলোর জন্য, for this material, the ratio become 3:1. Okay? If we use different material, like the instead of this one, you can have 2:1. You can have, or you can have 2.5:1. বুঝতে পারছি?
জি স্যার।
সো যেহেতু আমরা এই ম্যাটেরিয়ালটাই ব্যবহার করতেছি আজকে, এবং আমরা এই যে টেক্সট ডকুমেন্ট, হ্যালো,
হ্যাঁ স্যার, জি স্যার বলেন।
যেহেতু আমরা এই টেক্সট ডকুমেন্টের উপরেই কিন্তু আমরা আমাদের ন্যান্ড গেট এবং নর গেটটা ডিজাইন করব, তাহলে আমরা 3:1ই ব্যবহার করব। কারণ আমাদের 3:1 এর জন্যই কিন্তু আমাদের ফর 3:1 উই গট আওয়ার ডিজায়ার্ড রেজাল্ট। বুঝতে পারছি? So when you use a next different type of material, you use the same method, that means lab number 1. You use the same lab number 1, that means same method, to find out how much ratio we need. Is it 2:1, 3:1, or 2.5:1? You have to find out that. Then what? Then you do some calculation here with respect to 3:1 and do the math. বুঝতে পারছি? Okay. Now, since this is 3:1, we will do our, what is that? Do our program with respect to 3:1, because we already convert 3:1, 3:1. This is 1:1. This is 3:1, right? So that's why 3 is here, and since we have 3:1, that 1 is WN. So here is 1, here is 1. But why we have written 2? Because we have 2 MOSFETs. So if you do the math, the big math we have shown you in the lab class, previous lab class, you can get 2 and 2. Okay? So I know it will be 2 and 2, that's why I have written. So let's make the circuit description. We have 2 PMOS, 2 NMOS. So let's copy. Let's say this is MP. Let's write. Let's say this is MPB, because it is connected to B. Let's write MPA, because it is connected to A. This is, let's write, this is MNA, MNB. Okay. Where is the drain? Where is the source? Here is the source. Here is the drain. Here is the source. Here is the drain. Then where is the drain? Here is the drain. Here is the source. Here is the drain. Here is the source. Now we will do the noding. Okay? Let's write the node. Before that, let's do some coloring. So obviously, this is your node number 0. Right? And you have a capacitor. Wait a second. Okay, now we have a capacitor instead of an LED. Let's write CL. So draw. So this is also 0, right? Now next next color, let's say yellow. So A is our 1, node number 1. Okay. Next B. Let's say B is our blue. This is the B. Okay. Next, let's say the pink, purple one. Okay. This is our node number 1, 2, 3. Next, let's say this one. Okay. This is node number 4. Next one. Let's say this is node number 5. Do you have any more node? No, right? Okay. Let's write the node number. This is node number 0. This is node number 1. This is node number 2. This is node number 3. The middle one is node number 4. This is node number 5. Right? Okay. Our noding is done. Let's write the formula. So MPA. This is MPB. This is MNA. This is MNB. Okay. So PENH, PENH, NENH, NENH. So write the noding now. So the first one, this one, MPA is drain. So 4, 1, 3, 3, right? 4, 1, 3, 3. Next one is MPB. So this is also connected to 4. Then it is 2. Then it is 3, 3. So drain, gate, source, body. So 4, 2, 3, 3. Write the sizing later. MNA. So drain is upper one. So 4, 1, 5, 5. This one. Drain is 5, 2, 0, 0. Okay. Now the sizing. P type. The upper one, both of them are 3, 3. 3, 3 means 12, 12. Okay. The lower one are 2, 2. 2, 2 means 8, 8. Why 8, 8? Because 4 was 1. 12 was 3. So now we have 2. So that should be 8, 8. And the size and the length will be same. Now the VDD is 3, 3, 0, 3, 0, 5. Now we have two inputs. So let's write VA. Next one write VB. So first one is connected to 1. That's why 1, 0. Second one is connected to 2. So it should be 2, 0. And first one is 0, 5, 0.3, 0.3, 0.3, 20, and 40. Next one will be almost same. Just this will be 40. This will be 80. You know it already. Next one, the capacitor. Capacitor is connected to pin number 4. Transient analysis should be up to 80, right? At least 80 actually. The highest one should be at least. We have to see the highest at least 80. You can see more than 80, but less than 80 you cannot. So it should be 80. It's fine. Now the DC analysis or DC voltage we do not need, because DC is required only for finding out is it 4:1, 3:1, 2:1, something like that. For finding out that. So lab number 1 required DC analysis only. Other labs do not need. Okay. Now we can make a circuit file. How to make the circuit file? Click Save As. How to save it? Let's save NAND, NAND dot CIR, circuit. Text file should be all file. Now save. When I save it, you will see there is a NAND, right? This is the NAND. And this is a circuit file. You can see piece by circuit file. If I double click, this will come up. So I do not need this drawing anymore. So I'm going to erase the drawing. So this is my circuit file. This is too small. Okay, let's run. Nothing is here. So because we have to insert from trace, we have to insert. So what we need to see the capacitor, the VA, the VB. Remember the voltage, there's a not current, There's a capacitor, then VA, VB. If I run OK, this is the output. Now here, this green color is my output. And the blue one is my VB. This red one is my VA. So here, let's write VA. What is VA? This is A. This is 1, 0, 1, 0, right? Why 1? Because this is 1. You can see the 1. 0 because it is in the ground. That's why. Now B. What is B? B, first one is 1. Second one is 1. Next one is at the ground. That means it is 0. Next one is the ground. It is 0. So what is your output? Let's see the output. Why? Output is 0 because it is at the ground. See, the green color is grounded. Next one is 1. 1, 1, right? So here, what was your NAND output? For 0, 0, for 0, 1, for 1, 0, and for 1, 1. For 0, 0, the output was what? 1. For this one, output is 1. For this one, your output was 1. For this one, your output was 0, right? We already know it. And see the result. 0, 0 is 1. 1, 0 is what? 1. 0, 1 is 1. And 1, 1 is 0. So our result matches with the NAND gate. So our circuit is completed. Understood? Okay, got my point? So our simulation is completed. Now your job, today we will be finishing lab number 1, 2, and lab number 1 is finished, 2 and 3. So your job will be doing the NOR, okay? Take your time, take 10 minutes and do the NOR. And remember, my meeting capability has gone down to 40 minutes. I cannot hold a minute more than to 40 minutes because the premium account is gone. It is 40-minute limit. So 40 minutes, after 40 minutes, I need to start my meeting again. Okay, so you need to enter the meeting again. Got my point?
Yes, sir.
Okay, now CMOS NOR. I'm going to end the meeting for 10 minutes. Then I will start the meeting again. By this time, you do CMOS NOR because and show me the result within 10 minutes, please. Okay, do the NOR. You have the circuit. You have the, what is that? The text file to you. You have the circuit file. You have the text file.
Sir.
তোমাদের কাছে টেক্সট ফাইলটা আছে?
না।
Okay, I'm going to give you. Oh my, তোমার ফার্স্ট ল্যাব করো নাই?
জি স্যার, ফার্স্ট ল্যাব করছি। আচ্ছা হ্যাঁ, ওই লেভেলটা আছে। জি স্যার।
হ্যাঁ, ওইটার মধ্যে এডিট করবা। You edit on that text file, okay? So do CMOS NOR. What is NOR?
আর NOR এর মধ্যে হচ্ছে পার্থক্যটা কোথায় হবে?
আচ্ছা, পার্থক্য কোথায় হবে দেখো। What is the formula of NOR?
A plus B.
A plus B bar, right?
Yes, sir.
So previously it was A into B bar. So your design should be changed like this. Since it is plus, so it should be parallel at the N type, right? Understood?
Yes, sir. Yes, sir.
Now this is P type. This is N type. Now your sizing. No, now the sizing. Sizing was 3:1, right? For this lab. So here, how many MOSFET do you have in this path?
2.
2. So it should be twice the 3.
Okay.
So it should be 6, and it should be 6. How many MOSFET do you have in this path?
1.
So it should be 1 time of 1. Okay, 1 time of 1. 1 time means how much?
1.
1. How many MOSFET do you have in this path?
1.
So 1 time of 1. So this is your sizing. So 6, 6, 1, 1. Okay? Understood?
Yes, sir.
Now do it.
Okay.
Remember, my meeting will be finished within 2 or 3 minutes or 4 minutes maybe, automatically. So take a screenshot, take a look, and design. Okay?
Okay.